Welcome back. This is the final part of your investigation, which is the conclusion. You made it. This is where you answer your initial question about whether the treatment variable has an effect on the response variable. We need to look at our graphs to see if our results favoured an increase or a decrease in the response variable when the treatment was applied compared to the control. And you have to draw a conclusion based on one or more of your graphs and give evidence as to why you can or cannot make your claim. As mentioned in previous videos, there are also assignments and a booklet for you to use which may give you more information if you need it. And as always, talk to your teachers, talk to your classmates, and email me if you need anything. Using an arrow diagram to form a conclusion. You want to compare how many arrows went to the left or to the right. If 75% went to the left, then we can claim that the treatment caused a decrease in the response variable because our results tend to be lower for the treatment compared to the control. If 75% went to the right, then we can claim there was an increase in the response variable because our results tend to be higher for the treatment compared to the control. But if only around 50% of the arrows are going left or right, we can't claim that their treatment caused an effect because those results aren't convincing enough to claim they didn't happen by chance. So you have to have 75% or higher going left or right to show a decrease or an increase in order to make a claim that the treatment variable caused a decrease or an increase in the response variable. So that's your arrow diagram. The next is your dot plot. This one, you count how many dots are negative, 0, and positive. So similar to the arrow diagram one, when you count how many arrows are going left, down, or right, this one you count how many dots are negative, 0, and positive. And this one's probably the easiest to read. So if 75%, again, 75% is the magic number. If 75% of your dots are below 0, you can claim the treatment caused a decrease in the response variable. If 75% are above 0, you can claim there was an increase. But if only around 50% of the dots are positive or negative, then you cannot claim that the treatment variable caused an effect. So you have to have 75% or higher going in the negatives or in the positives to show that there was a decrease or an increase in the response variable caused by the treatment. The final thing that you can use to analyze and make a conclusion is your box and whisker graph. And so again, it's 75%, that's the magic number, and that's your lower and upper quartiles. So you're looking for where does the majority of the data sit on the scale. If the upper quartile is negative, you can claim that the treatment caused a decrease in the response variable. But if the lower quartile is positive, you can claim that the treatment caused an increase in the response variable. But if neither of those things are true, you cannot claim that the treatment had an effect on the response variable, because even if you have more than half on the in the negatives or in the positives, that could have happened by chance. So that's why you have to have 75% or higher to make it convincing enough to make a claim at the end. Once you have made your claim and given your evidence why, you talk about your limitations, improvements, and areas for further study. That's so that you can make continual improvements and get a better understanding of the world. So you don't just do an investigation, you say, okay, that's it, we know everything about this topic, we're all finished. You say, okay, here's some limitations that we had, things that that we could have done better. This is a way that we can improve it, and this investigation can lead into these other areas of study. So we're always improving on our understanding of the world, making the world a better place. I'll show you the example from the heart rate and exercise. Okay, so looking at the arrow diagram first, it's kind of hard to see in this one, but if we go to the table, you'll be able to see, let me see it. You can see that we have 27 blue here. Actually, you can't see it super well, but there's 27 blue and 3 pink. So that means there's 27 positive and 3 negative. That means you've got 27 arrows going to the right and 3 going to the left. So the majority of your arrows are sloping to the right. Now, if you find out you've got 27 arrows sloping to the right and 3 sloping to the left, so you have 27 out of 30 is sloping to the right. So what you do is you do 27 divided by 30, and then you go times 100 to find the percentage. So this is 90%. That's over 75%. So that means that because 27 out of 30, which is 90% of your arrows, are going to the right, that's over 75%, and we can claim that the treatment variable caused an increase in the response variable. That's the same for the dots. 27 of these dots are positive and 3 are negative, so 27 out of 30, which is 90%, that's over 75%, are positive, so that means that showed an increase in the response variable. We can say that's caused by the treatment. Same thing with our box and whisker plot. Our lower quartile is above 0. So because your lower quartile is above 0, that means 75%, 25% plus 25% plus 25%, 75% of your data showed an increase in the response variable, and we can say that that was caused by the treatment variable because we controlled the conditions. We changed it ourselves, we controlled the conditions. So this is how you'd write your conclusion. Based on the box and whisker graph, arrow diagram, and dot plot of differences between the heart rates of 12-minute twice students, exercise appears to cause an increase in heart rate compared to being at rest. Now you only need evidence from one of your graphs. I've got all 3 just to show you how to do it, but you only need one of them. If you're looking for the easiest one, I would suggest the dot plot. Now you need to put your evidence. I can make this claim because the lower quartile is 20. Your lower quartile is 20, which is above 0. Over 75% of the dots are positive, 27 out of 30. And over 75% of the arrows are pointing to the right, 27 out of 30, showing an increase in the heart rate for at least 75% of all the participants when exercising compared to at rest. That is your full claim with evidence. Now you need to talk about the limitations, improvements, and areas for further study. So you only need to talk about a little bit for each of these things. So in conducting this experiment, I noticed that some participants stopped doing star jumps to rest. Some carried on, but some didn't start doing star jumps again. This is a limitation of the study, as it may have caused their heart rates to be different, probably lower than it would have been had they continued doing star jumps for the whole 2 minutes. So that's a limitation of the study, because it caused their heart rate to be probably lower than it would have been. An improvement that we can make is what I've written. It's important to make the experiment more accurate by creating as similar conditions as possible for all participants. Next time, if a participant chooses to stop doing star jumps, I will remove their data from the table so that it does not affect the overall results. It's important to be accurate because we're making a claim from this that other people are going to read. Further study, it would be interesting to look at how different types of exercise affect heart rate, such as running or yoga. It would also be interesting to look at how the duration of the exercise affects heart rate, so how long you do it for. This may be useful for doctors as they can suggest different forms of exercise to their patients depending on their needs. So that's just a way that it can be used. So that is the full report. Really well done for making it this far. I wish you all the best. Good luck with everything, and thank you for watching. See you next time.